Now we're actually going to solve radical equations and inequalities. So let's just start right to it. Here's a radical equation. So a radical equation is an equation that has a radical in it. We've got 2 square root x plus 5 equals 8. So just like solving any normal equation, don't write this, just watch. If this was just 2x equals, well, let's do plus 5 equals 8, what would you do first? Minus 5, and then you would divide by 2. If it was just 2x equals 8, what would you do first? You would divide by 2. So what I need to think about is the square root as one thing and get that square root isolated. So is there something in front of it? Yes, there's a 2. 2 times the square root, which means I'm going to do what to get rid of the 2? Divide by 2 on both sides. So now I get the square root of x plus 5 is equal to 4. Yeah, so how do you undo a square root?
Square the other side.
You square both sides. So to undo a square, we square root things. To undo a square root, we square things. So they're inverses of each other. So because I have that square root there, if I square a square root, it's going to make everything go away, which would just leave me with x plus 5. What I do to one side, I have to do to the other side. So that means I have to square the 4, which would get you to 16. So x is equal to what? Now let's think about excluded values in my domain. What values do I need for my domain? X has to be greater than or equal to what numbers?
Can't be negative.
Can't be negative 5 or less, right? So if we take x plus 5 and make it greater than or equal to 0, x is greater than or equal to negative 5. Is 11 greater than or equal to negative 5? Yeah, so we're good. So we checked our solution. I'm okay. It's greater than or equal to negative 5. It's within my domain. It does not get me some crazy negative number underneath.
Maybe it does.
You could check it and actually plug in 11 if you wanted to do that instead. What's 11 plus 5?
16.
16. What's the square root of 16? 4 times 2, is that 8? Yeah. So we know we did it right.
Can we do it like that without...
Yep. Okay. All right. On to the next. See if we can do this one. 3 times the square root of 2x minus 1 equals 6.
Boom. 4.
What are we going to do first? Divide by 3 on both sides. So then we get the square root of 2x minus 1 equals 2. Next move. Square both sides. So we get 2x minus 1 is equal to 4. What's next? Add 1. 2x is equal to 5. X is equal to 5 halves. So now we could check it by plugging it just right back in there. What's 2 times 5 halves?
Oh, 5.
It's 5. 5 minus 1 is
4.
square root
2.
times 3. 6. Does it work out?
Calculate.
Yes.
Okay.
So then we got our answer. What would the domain need to be? All values greater than or equal to what? Positive 1/2, which 5 halves is greater than 1/2, right? So that makes sense. Okay, so far so good?
Yep.
All right. Do you want to write down the steps? Let's skip this whole slide. I don't think you guys need to write this down. All right, let's get to the easiest ones you will see.
Isn't that just set x minus 5 equals 7?
Yeah. If you have a radical on both sides of your equal sign, you should be thinking, yes, that's wonderful. Because on the left side, do you have anything in front or behind your cube root? No. On the right side, do you have anything being multiplied or being added or subtracted? No. So to undo a cube root, what do you think you're going to do? Cube both sides. So then what happens? We're just left with x minus 5 equals 7 minus x. What would you do next?
Minus 5.
6.
Plus 5.
2x equals 12.
Add x. 2x equals 12. X is equal to 6. Let's check it. On the left side, 6 minus 5 is 1. The cube root of 1 is 1. 7 minus 6 is 1. The cube root of 1 is 1. So we're good.
And it's going to ask you for the domain, or like the x is...
Well, I mean, these won't ask you for the domain, but it's just something to connect it to that you can think about. Okay, those will be your easiest ones. Would our answer change if it was a square root?
No.
No, it would not change if it was a square root. Because isn't the square root of 1 also 1?
It depends on who you're asking.
What do you mean, depends on who you're asking? These are going to be your trickiest ones.
So you...
So we got to get the square root all by itself.
So you square both, right?
So before I can do any squaring of anything, I have to move that 3 to the other side.
So it's not under the...
It's not underneath the radical, no. So then I would get 2x minus 3. Right? Is everybody okay with that?
Yeah.
That's a little...
So now my radical is all by itself. So I'm going to handle the easy part. I'm going to square that, which means I'm just going to be left with x plus 1. But now when I go to square the right side, I have to square that as a group together, which means we're going to have to do what?
Is it negative 9 or positive 9?
Multiply it out. So it's going to be 2x minus 3 times 2x minus 3.
And then distribute.
Yep,
Why can't you just distribute the exponent?
because that's not proper mathematics. Don't do that. 2x times 2x would be 4x squared, negative 6x, negative 6x, positive 9. Combining like terms is going to get us what?
4 squared minus 12x plus 9.
12x plus 9 equals x plus 1. What would you do next? Move everything to the right side. So I'm going to minus an x, minus a 1. So I get 0 equals 4x squared minus 13x plus 8. Whew. Is that factorable?
Yeah.
Yeah, it is. 32 to get 13.
No, 9.
Hold on, am I making that up? 32.
16?
I don't think you can
16
get...
and 2.
Maybe it's not factorable?
No, it's not.
So we gotta use the quadratic.
Oh.
Let's see what that happens to look like.
Doesn't look like anything.
Maybe it doesn't look like anything.
13.
So x is equal to negative b, so positive 13, plus or minus b squared, which is 169, minus 4, times our a, times our c, all over 2 times our a, which is 8. 169 minus 4 times 8 is 41. So 13 plus or minus the square root of 41. Why is the square root of 41 nice for us? Okay, simplify that. No. So there's our answer.
Alright.
Okay?
Yeah.
So those will be the hardest ones where you have to do that. There's not like one like that on your final exam, but you will get one on your Chapter 8 test. You'll have to do that. Okay? Equations. Think you got that?
No.
All right, let's try this one. See what happens.
used to do what we just did again?
Yep.
Jeez. Loonies.
All right, so some of you guys already got to jump on it, squaring both sides. I'll take the left side, that gets us x minus 1. Multiply out that right side, see what we all get. We're getting x squared minus 4x plus 4 when we multiply it out. So then when I move everything over, I'm moving it to the right, x squared minus 5x plus 5, not factorable.
So you leave it?
Nope.
Oh.
Quadratic formula,
Oh.
or complete the square. Which would you guys pick?
I don't remember complete the square, so you might as well do that one.
Well, I would not complete the square on that because my b is an odd number, so then that would mean I would have to deal with fractions.
Looks like we're using quadratic.
Yeah, so 5 plus or minus
Square root.
25 4ac all over 2 times your a. 25 minus 20 is 5. Can I simplify that any further? No. Done. Okay? All right, so those are our equations. These are going to be your hardest types of equations right here. Only because you're going to have to do that.
Yeah.
And then you're probably going to end up with a quadratic that's either factorable or you'll need to use the quadratic formula on it. Okay? That's what makes it the most challenging part. So now let's get to some inequalities.
Oh, I thought we were good.
Now we're going to skip that one. Here we go. So the square root of x plus 1 is less than 2. I'm not going to give you crazy inequalities that you're going to have to do a whole bunch of different craziness to them. So now we need to think about every part of your inequality, or of your radical, not your inequality. What would be my domain of just that radical?
X is greater than.
X has to be greater than or equal to negative 1. So I'm going to do a quick sidebar here. I'm going to take that x plus 1, set it greater than or equal to 0, which tells me that x has to be greater than or equal to negative 1. I'm going to hold on to that fact as I go and do my solving of this. Okay, so now let's solve it like we just did our equations. What would you do? Square both sides. So then we would get, go over here, x plus 1 needs to be less than 4. Everybody good so far? So x has to be less than 3. So, right now, I just got that x has to be less than 3. Well, what numbers are less than 3? 2, 1, 0, negative 1, negative 2, negative 3, negative 4, and so forth, right? But didn't we say that in order for this to not get a negative underneath it, it needs to be larger than negative 1?
So what's the domain restriction?
So let's think about this graphically on a number line. Which number would be on the left side? Negative 1, closed dot. What number would be on the right side? 3, open dot. If I need to be less than 3, that's everything to the left,
So it's an and.
but I need to be greater than negative 1, it's going to be an and. How do we write that?
X is.
Put x in the middle,
Yeah.
negative 1 on the left, 3 on the right, equals 2, not equals 2. Okay? that make sense?
Mhm.
So yeah, it's easy to get to this, but then we have to think about this, the original domain restrictions that we have. Because I need to stop once I get to -1. Because once I go beyond -1, I'm going to get to numbers that I can't have because that would get me a negative underneath my square root sign. All right, let's do this one. Last one. Square root 2x minus 3 less than or equal to 5. So let's take care of those excluded values first. If I set that 2x minus 3 greater than or equal to 0, x needs to be greater than or equal to what?
3 halves.
3/2. Good. So keeping that in the back of our brain, solve the inequality just like we did before. Squaring both sides would get us 2x minus 3 is less than or equal to 25. Add 3, so 2x is less than or equal to 28. So x needs to be less than or equal to 14. Well, we can go less than or equal to 14, but then I'm going to have to stop once I hit 3/2, because I can't go beyond the 3/2, right? So if you think about it as a number line, 3/2 is here, 14 is here, close, close. I need to be less than 14, but I need to be greater than 3/2. So where is the overlap in between? So how do we write our answer?
3/2 is less than x. X is
Less than or equal to 14. Good. Okay. Good with that? All right.